How are you, everybody who is watching this video? I would like to take this opportunity to welcome online students and even some physical engineering students who have joined in this class. If it's the first time to join me, I would like to take this opportunity to welcome you into this very interesting moment of learning about telecommunication engineering. My name is Olenjolai. I'm very happy to have you today. And I've prepared a very important contents about radar and navigation aids. Radar is one of the means of communicating between the two distant sources of the information. So remember that, what are the requirements for these contents? Well, the requirements, just you should have a fresh mindset, and then you should have an exercise book, should have a pen, a pencil, a rubber, and a ruler. Then if you have all of those requirements, let us go together into this moment of enjoying about the beauty of radar and navigation aids. So, for myself, I'm ready to take you into the contents that we have. But I have some physical students that may appreciate their presence. How are you, students? We are fine. Real? Do you like telecommunication engineering? Yes. Wonderful. Today the class is actually consisted by a number of ladies. Ladies, how are you? We are fine. Gentlemen, how are you? We are fine. All the students, are you ready for radar and navigation aids? Yes. Yeah, good. So, the module is called the radar and navigation aids. We are still in chapter 2, but we are winding up this chapter by just this lecture 60, and then I will leave an assignment. Lecture 6 is about the principle of operations of the pulse primary radar. Let us do the quick review of what we've covered in lecture 5. In lecture 5, firstly, I taught you the definition of the terminology of the word called the pulse primary radar. Pulse primary radar. And in that definition, we say that this pulse primary radar, it uses short burst of 40 of pulses. That's what this is the part of the definition of the word pulse primary radar. And then, after discussing about that, we explained also that the pulse primary radar, this is the very important radar, and it has some advantages compared to the continuous wave primary radar. And then, we just pay attention about the block diagram, the general block diagram of pulse primary radar. Pulse primary what? Radar. And then the next part, which was the last part, we mentioned about parts. Parts of pulse primary what? Primary radar. So that's what we have mentioned or we have discussed. So let us remind ourselves, the first part, it is what? Pulse what? Generator. The second part, because these are the blocks that we had. The second part is called what? RIF or radio frequency what? Oscillator. The third part is what? Pulse what? Pulse modulator. This is the steady block. And then the next block is what? A radar transmitter. So, transmitter, radar transmitter unit. Then the next part is what? Duplexer. Then the next part is what? Transmitter. Then the next part is transmitter again. Transceiving and receiving antenna. Yes, so TXC and the RX antenna. The next part, a low noise what? Amplifier. Low noise what? Amplifier. Number 8 is what? It is called the mixer. Number 9 is called what? Local oscillator. Number 10 is called what? Pardon? IF. We don't call it IF. This abbreviation we just call it intermediate frequency amplifier. Number 11 is what? Detector. So detector, aka the modulator. Number 12 it is what? Video amplifier. Number 13 is what? CRT, cathode ray tube display. And then I just showed you about those displays and the different parts. So today we are going to learn the principle of operation. So the principle of operations of pulse primary radar is actual. This is the descriptions about each block. So when you've been asked that to explain the principle of operations of a particular type of radar, you have to think about how can you explain the function, the primary function of each block in that general block diagram. So today we'll be paying attention and learn about the function of each block. And the function of each block which will actually give us the overview about how this pulse primary radar operates. So, ladies and gentlemen, let us focus on principle of operation. These are the fundamental concepts. Principle of operation of pulse primary radar. Pulse primary radar. Are we together? Yeah. So, class, say principle of operations of pulse primary radar.
Principle of operation of pulse primary radar.
Okay. So, the principle of operation of pulse primary radar. Say principle of operation of pulse primary radar. So simply we say that the principle of operation of the primary radar, of the pulse primary radar, of the pulse primary radar, simply is a description. This is the description of primary function of each block in the general block diagram, the general block diagram of pulse primary radar. Pulse primary radar. So the principle of operations of the pulse primary radar simply is a description of what? Of primary function, because you can find one block can have more than one function. But among those different functions, one of them is primary. It means that it has been given a high priority. A primary function of 40 of each block in the general block diagrams of the pulse primary radar. And that's why I have taught you about the general block diagrams of the pulse primary radar before I teach you about its principle of operation. So when we're explaining about the primary function of each block, for you, you have always to refer your general block diagrams of the pulse primary radar to understand the connection. And remember that, I'm not sure that, I think that not this point. Any radar system consists three main parts. Remember this, it's just like in communication. Any communication or telecommunication system consists of three main parts. The first one, we call it transmitter unit. The second one, we call it medium or media. The third one, we call it receiver unit. That is in case of telecommunication or communication system. And any radar system consists mainly three parts, right? Which are a little bit different from from the one that we had in communication. So the first main part that you have to think, whether it is primary radar or secondary surveillance radar, you have to think about this one. The first one is called the transmitter or radar transmitter. Radar transmitter or transmitter units of the radar system. Say transmitter unit.
Transmitter unit.
The second part, which is very important and you usually see in radar system, is called the antenna. Say antenna.
Antenna.
And simply this one we call it transceiver antenna. Transceiver antenna. Let me just write this one. Transceiver antenna. So transceiver, this is the word that which has been consisted transceiver. They've been consisted by the two words, trans and then va. Trans, this is a word that we extracted from transmitter. Then VAR, this is the word comes from receiver. So transceiver antenna, it's an antenna which it can propagate electromagnetic waves. At the same time, also it can be used to receive electromagnetic waves. This transceiver antenna, we have them in our mobile phone, we have them in our computer, we have them in our iPads, we have them in smart television receiver. So we use these transceiver antennas in most applications rather than have a separate transmitting antenna and receiving antenna. Are we together?
Yes.
Remember that in case of telecommunication system, this transceiver antenna we have a special name. We call it medium. Right? But for the radar, antenna is very important. And whenever you visit the radar site, you will see the antenna even more than the transmitter unit and receiver unit. And usually, the radar antennas are actually huge for the large radars or for the stationary radars. Then the third part is called the receiver unit. Say receiver unit. Say receiver unit. So we have transmitter unit, transceiver antenna, receiver unit. That's what you have. Those are the three main parts of 40 of the radar. So even if you want to explain about the principle of operation of the particular type of radar, you have to think also about the three main parts. Are we together? Yeah. So then we have a number of how many blocks did you have in our general block diagram that we covered in lecture 6, lecture 5? How many are they? 13. So let us start to explain the primary function. Some of these blocks are new for the second year ordinary diploma students. For the purpose, for the sake of teaching, I might explain a number of functions of the one block. But in case that you have been asked to explain the principle of operation, you have to select one main function of each block. Right? I know, for instance, you don't know anything about video amplifier. I know also that you don't know anything about low noise amplifier. Those are the new terminologies. Even if when I've been teaching you, I ask you that, can you mention one of the electronic circuit which is working as a mixer? Also, you told me that you have no idea. So the first block, say the first block. The first block and primary block is called the Class A pass generator. Say pass generator. We know that we have AC generators. Do you know them? Those used to function whenever that the hybrid or the high grid went off. Right? So when you talk about pass generators, actually they don't produce sound like the one you used to hear in the street. But they are very important generators because they actually generate passes. So what is a pass generator? Because this, I know it's a new terminology for you. What is the meaning of a pass? As telecommunication or electronics engineering student, what do you understand when you hear about a pass generator? So we say that a pass generator is either electronic circuit, or a piece of electronics, test equipment, a piece of electronic test equipment used to generate what? Used to generate the rectangular pulses. Rectangular what? Pulses. When you say used to generate rectangular pulses, it means that this is the pulse. However, that we have drawn them in terms of two-dimensional plane. So when you call it is pulse, so you say this is voltage, this is time. So you say that generate rectangular pulses. This is what we call pulse. These are the rectangular pulses. But remember that all of these pulses have the same dimension. So this is voltage, and that is time. Figure 1. The rectangular pulses. So that's the meaning of pass generator. So pass generator, it's what is operating. A pass generator is either electronic circuit or a piece of electronics test equipment used to generate what? The rectangular pulses. I said it's operating. What is pass generator? Read it quickly. Matthew, you yourself read.
It's either electronic circuiting or a piece of electronics test equipment used to generate the rectangular pulse.
So remember that in electronics, remember that the height and the width of these pulses is the same. It's just because I drew it by using the hand. And my dear students, you have to differentiate pulses and square wave. What the difference? Here's the difference. In case of the square wave, this is the axis for the voltage, and this is the axis for the time. Then, when you say that this is the square wave, any square wave, remember that this is 0, 0, then this is positive, for instance, that it depends parts of how many voltage. And then this is the square wave. And this is the confusion that many electronics and telecommunication engineers use to confuse. These are the rectangular pulses, and this is figure 1B. This is what we call the square wave. Say square wave. Remember, the pulse generator generates pulses, but this is the contradicting issues for many electronics and telecommunication engineering students. Right? Right? What the difference? So pulses always are, just means the waveform, the nature of the pulses are always on one side of the time axis. I say this, stop writing, stop drawing. Asia and your colleagues. Let me repeat. The difference between pulses and square wave is actual. You can differentiate them by using their waveform. Right? The waveform of pulses are always located on the positive side of the time axis. While they are actually that the waveform of the square wave, they are actually located on top, positive side, and negative side of the time axis. Are we together? Okay. So it means that the pulse generator in general, in the pulse primary radar, its main function is to radiate or to generate rectangular pulses. So we say that the pulse generator of pulse primary radar, pulse primary radar generates a short burst of 40 of rectangular pulses. And this short wave of burst of rectangular pulses, that's what we call it information signal. Information, what is class? Information signal. So what information is carrying is actual. We'll carry the information once it will be reflected by the target. And it will bring the information about radar parameters. Are we together? Wow. The second block is called the RF oscillator. Class A RF oscillator. Class A RF oscillator. RF is abbreviation of 40 radio frequency. What the means of radio frequency? Yes, because you know the long term of RF, radio frequency. And what the means of radio frequency? As telecom engineer. What the means of radio frequency? Jafari. So up to this time, you don't know the meaning. We discussed about RF. We discussed it. I told you in lecture 2 or lecture 1. We call it lecture 1, but it's the second lecture. I told you about the meaning of radio frequency. And I discussed about 7 spectrum. And I told that which spectrums are we using in communication. But you forgot. You need a test to boost you, isn't it? Okay, so the RF oscillator or radio frequency oscillator we say that is electronics circuit. This is the electronic circuit that produces what? Produces the RF, produces what? The RF periodic key, produces the RF periodic key, or produces the RF oscillating signal. So periodic key, signal, or it can produce the RF oscillating. Oscillating what? Oscillating signal. Oscillating signals, the periodic signal, or the RF oscillating signal are the frequency of radio frequency. At the frequency of radio frequency or RF signal. Then the RF oscillator, it always conveys. So this one conveys the direct current. Convey what? The direct current originating from the power supply. From the power supply into an alternating current signal. So we say that the RF oscillator conveys direct current. Say direct current. So most of oscillators, they just need a DC current. And then once you receive the DC current or direct current from the power supply, then it can convert it into alternating current signal. Alternating current, it's a long term of the word AC. It's a long term of the word what? AC. So AC, it means alternating current. AV, it means alternating voltage. So most even this RF oscillator, it needs the direct current from the power supply. One of the important parts in any electronic system is power supply. Because without power supply, nothing will be done. It's just like you yourself. One of the important things in your life is food. Tell your neighbor, one of the important things in your life is food. Because whether you are happy or you are unhappy, food is compulsory. Whether you pass the exam or you fail, food is what? Compulsory. Whether you are an orphan or you have parents, food is what? Hey, if food is not compulsory, okay, take your semester 2 budget and then give to your neighbor. Then yourself survive without food. Because do you remember that somebody who went and asked the king, what are the requirements for me to earn the kingdom of heaven? Then, okay, keep all the 10 commandments. Okay, I've done it well since I was a child. Then, another test. Go and sell everything that you have. Then give, need, or poor people. You know what happened to that man? What happened to that man? So the first question, what am I going to eat if I'm going to sell all the properties? I'm going to die. In case that food is not important for you, just take the budget. Whenever your parents send the money to you, just give your friend. Give. If it is 10,000, give it to him or her. I know within a short time, say, hello, my friend, I changed the idea. Please, I want to meet you. Give me my money immediately. So it means that the primary function of RF oscillator in pulse primary radar system is to generate the RF carrier signal. So remember that when you're discussing each block, now stop writing, refer your block diagram. Check those two blocks that we have drawn. I say stop writing, refer your block diagram. Check the two blocks that we have been discussing. So where are they? Do we find these two blocks in the transmitter part, antenna, or receiver unit? Pardon?
Transmitter unit.
Transmitter unit. So have you seen those blocks? So these blocks are the input. They work in transmitter, the input to the what? Transmitter. Right? What is the input? The output of pulse generator and the output of RF oscillator will be the input of pulse modulator. That's the principle of operation. Are we together? Can I repeat? Let me repeat. Pulse generator, it's a source of information. It's the input of transmitter, of radar transmitter system. In case of the pulse primary radar. RF oscillator, it's another input or source of information that's required by the pulse modulator. So once the RF oscillator generates the radio frequency carrier signal and the pulse generator generates the pulse at the information signal, then the output of RF oscillator and the output of the pulse generator will be the input of the pulse modulator. Are we together? So now, if that's the case, let us go to block number 3, which is called the pulse generator. Say pulse generator. Sorry. Pulse what? Modulator. Say pulse modulator. Say pulse modulator. So a pulse modulator receives its input from the pulse generator and the RF oscillator. And the RF40 oscillator. So a pulse modulator receives what? Its input from what? Pulse generator and the RF40 oscillator. Are we together? Once it receives, then we say that it modulates the pulse, which we call the information signal, information signal, and the RF carrier signal. So then the homework, I want to leave it to you. Which type of the modulator are we using in that past primary radar? Are we using AM modulator? Or are we using FM modulator? Or are we using phase modulator? Or are we using amplitude shifting key modulator? Or are we using frequency shifting key modulator? Or are we using binary shifting key modulator? Or are we using quadrature amplitude amplitude modulator? Then, or are we, which type of the modulator are we using there? That's your homework, right? For me, just I told you that it will modulate the pass and what? Carrier signal. Then this one, once it's modulated, it produces so the output signal of the pass modulator, or in the block of pass modulator, is called the modulated signal. Class say information signal. Say information signal. Say pass signal. Say pass signal. And the RF carrier signal. So this one, it produces what? Modulated signal. So modulated signal, it's actual combinations of the pass, which is information signal, which will actually give us the information once it's been reflected, and what? RF carrier signal. So it produces modulator signal, pass modulated signal. Sorry, I forgot the word pass. So the name of that signal is called the pass modulated signal. Say pass modulated signal. And this pass modulated signal is a train, which is a train, of repetitive passes. It's a train of 40 repetitive 40 passes. Say repetitive passes. Again, say it. So the nature of pass modulated signal is a train of repetitive 40 passes. What does it mean? If you do remember that, when you've been going through the what? Through the video, the nature of this carrier signal, let me just see, draw this one because it's F, draw it here. This is voltage, this is time. Remember that engineering is all about numbers, it's all about formula and equation. Wait. It's all about what? Diagrams, it's all about tables, it's all about what? Graphs. So, this carrier signal, or the signal from the RF oscillator, will be a very high frequency. This is the RF. So it is sinusoidal, but it's a very high frequency. Okay? So this is the graph of what? Graph of RF carrier signal. Then the graph of now modulated signal, if you do remember what I taught you by using video technology. This is 0, this is time, it's actual, this is voltage, then the graph of modulated signal. So the graph of modulated signal, it's this one. I don't know about you, because for me, I love this stuff. So I like to learn the ideas by using diagram, telecommunication ideas by using diagram, by using numbers, by using graphs. I don't know about you. So because I don't know about you, let me give that responsibility to your neighbor. Ask your neighbor, do you like numbers in electronics? Do you like numbers in telecommunication engineering? If your neighbor says yes, and then tell him or her, please show me some numbers. Show me some telecommunication numbers that you know or you have. Remember, the widths of these paths is still the same. So this is figure what? Remember, this is figure 2. You have to draw it after RF oscillator, that figure. This is figure 3. So this one we say that the pulse modulated what? Pulse modulated what? Signal. So this is modulated. This is the carrier signal. I drew the graph or the waveform of the pulses. Right? Right? So this actually simplified, this waveform simplify the concept about each block, because the blocks actually, the waveform, give you the difference. And sometimes if I could be you, I just want to know about this waveform. And then I can use those waveform to develop and even actually to compose a definitions or the primary function of that particular block. Are we together? Class, are we together? Okay. So have you drawn this? Huh? Okay. Make sure to use pencils in your drawing. That's why I told you the requirement for this course or for lecture 60, it's actual fresh mind, a pen, a pencil, a rubber, a ruler, exercise book. The pulse modulated the signal. The pulse modulated the signal. Class A, pulse modulated the signal. This one is fed to the pulse radar transmitter unit. Pulse radar transmitter unit. So go back, refer your general block diagram, and then find the block that's called the pulse modulator. Have you seen it? Yes. The next block is what? Radar transmitter. Radar transmitter unit. Say radar transmitter unit. Say radar transmitter unit. Yes. Thank you very much. A radar, a pulse radar, you may say also a pulse radar transmitter unit. Fine. Pass radar transmitter unit. A pass radar transmitter unit receive its input from the pass modulator. What does it do? So say the transmitter amplifies transmitter amplifies the pass modulated signal, by using high power amplifiers. So the transmitter amplifies the pass modulated signal from the modulator unit by using the high power amplifiers. Say high power amplifiers. Say high power RF amplifiers. Again, say high power RF amplifiers. In electronics, we have small signal. Stop writing. In electronics, we have small signal amplifiers, and also we have large signal amplifiers. Isaac, you are not listening. Also, in electronics, we have high power amplifiers, and also you have low power amplifiers. However, that we used to have intermediate amplifiers. But the main focus we used to call them high power amplifiers and low power amplifiers. Or we call that small signal amplifiers, large signal amplifiers. Right? However, in some cases, like in case of radar, in case of television, transmitter or receiver, we have also something we call it intermediate frequency. But simply, intermediate frequency is still actual, like, okay, it's a middle frequency between some frequencies and between the two frequencies. That means of intermediate. So once it amplifies the pass modulated signal into the desired pass modulated signal of the particular strings, or of the particular strings, then the pass radar transmitter transmit the signal or the amplified modulated signal from the transmitter towards duplexer. Right? 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 Yes. So the pass radar transmitter transmit the amplified, because now it will be called the amplified pass RF, the amplified pass RF modulated signal. Toward the duplexer. So the pass radar transmitter transmit the amplified pass RF modulated signal towards the duplexer. So what will be the difference between the amplified pass RF modulated signal and the pass modulated signal? So the difference will be actual in terms of gain and in terms of what? In terms of amplitude of those two signals. Stop writing. The waveform of the amplified pass RF modulated signal from the pass radar transmitter unit will be shown like this. This one is voltage, and that one is time. Hello? Then, so remember that this is not amplified. I say, stop writing, stop drawing, listen and watch, and note the changes. So this is figure what? Class figure what? 4. What the name of the figure? A amplified pass RF modulated signal. Stand up. So what the difference between figure 1, figure 3 and figure 4? Student, listen and make a follow-up. You remember these days. I'm trying my level best to teach you in a very simple language and clear. But remember that I'm leaving some tasks there for you to make sure that you think outside that box. That is inside the box. You have to learn to think outside the box. So what is the difference between figure 3 and figure 4? Okay, good. If the difference is the amplitude, that is good. That's all about it. There are the pass radar transmitter unit. The next block is what? A? Class, the next block is what? A? Pardon? Listen how your neighbor is pronouncing that terminology. Pronounce it again. Huh? Pardon? Excuse me. Huh? Thank you. Say duplexer. Again. Again. Ask your neighbor, are you going to call your firstborn duplexer? So to switch the antenna, ask your neighbor, are you going to call your firstborn duplexer John? Duplexer Matthew? Duplexer Jafari? There's no need for registration number because no any students in these institutions is called duplexer. The name itself is very unique. Say duplexer. Again. Again. Duplexer. Okay. What is duplexer? What the meaning of 40? Yeah? Pardon? Pexa? Again? So a duplexer is a microwave switch. Duplexer is a microwave switch which connects the antenna to both transmitter and the transmitter section and the receiver section. Alternatively, that's the meaning of duplexer. What is duplexer, class? Is a microwave what? Switch. So ask your neighbor, what's the meaning of microwave switch? Because you have accepted that a duplexer is a microwave switch. Then another question, what the meaning of microwave switch? Because if you don't know the meaning of microwave switch, you didn't understand the meaning of duplexer yet. So ask your neighbor and wait the response. What do you understand about the microwave switch? It's a normal switch, mechanical switch, electromechanical. Which type of that switch? And why it has been called microwave switch and it's not a radio frequency switch or maybe infrared switch? I said ask your neighbor. You don't have neighbor, that one. Mbali what? Nimwambia kupige ngumi kama ifiki. I ask your neighbor and listen. What the meaning of microwave switch? As a telecommunication engineer, not as electronics. As a telecommunication engineer, what do you understand about microwave switch? Have you ever seen the microwave switch? That's the question. So a duplexer is a microwave switch which its primary function, I said it's operating, which its primary function is to connect, which connects what? The antenna to where? To both what? Transmitter section or unit and the receiver section. Alternatively, gratitude, you are not in this class. Isaac, who told you to sit down? Stand up. Sit down. So, a duplexer is just a switch or telecommunication switch. Its primary function to connect the antenna to both transmitter and the receiver. Alternatively, what does it mean? This is the simple logic. When the transmitter is transmitting information, the receiver has to be switched off by duplexer. Listen, simply, this is the simple block of 40 of transmitter unit. This is the simple block, or let's say, this is duplexer. We didn't reach the antenna yet. And this is what? Receiver. So this is transmitter, this is receiver. Okay? So remember that both transmitter and receiver are connected direct to the duplexer. This is duplexer. Duplexer. So what happened? When the transmitter query or when the transmitter want to transmit the information or propagate, just transmit information to the antenna. Remember, duplexer is connected with what? With an antenna, which we call transmitting and receiving antenna or transceiver antenna. Then what happens? So when a transmitter transmits information to the duplexer at that time will switch off the receiver not to receive information. So the route will be actual one way for that case. Then I say stop writing, concentrate and look. So suppose that this is the target. So remember, the transmitter has transmitted the high power signal or high power pulse modulated signal towards the target. So then when it has been transmitted, then the pulse will be reflected, because remember that this pulse, this amplified pulse modulated signal, it will be propagated with the speed of light. Okay? So when the echo will be detected by the receiving antenna or by this antenna, then the antenna sends the information to duplexer. And when it sends the information to the duplexer, it tells the duplexer, hello duplexer, I have a feedback or I have echo from the target. So I ask you, duplexer, switch off the transmitter, and turn on what? Turn what? Receiver. To receive what? The weak RF signal. Are we together? Yes. So there is no any principle. It means that the delay might be very, very negligible. Within a fraction of a second, the transmitter can access the duplexer, and within the next fraction of a second, the receiver can access the duplexer. Within the next fraction of a second, the transmitter accesses the duplexer, and within the next fraction of a second, the receiver accesses the duplexer. So that is how the duplexer switches the antenna to both transmitter and receiver. If you have been learning well about the fundamental of telecommunication engineering, then what the form of communication used by the duplexer? Which form does the duplexer use to connect the antenna to both transmitter and receiver? If you have understood. Half what? Half duplex. What are the other names of half duplex? Half duplex. Yes, because simplex is just one transmission, one direction. Right? Half duplex, it is what? Transmission and reception, but not at the same time. Right? Full duplex, it is what? Transmission and reception at the same time. That's all about telecom engineering. So the duplexer is actually uses the principle of half what? And that's why it is called the duplexer. It comes from the word duplex. Ha! 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 You learned about duplexer, half simplexing, full duplexer, but you forgot them. You left them once you passed that module. You had the B or you had the A, and then you told duplexer, bye-bye. Are we together? So remember that the nature of the waveform still like this one. Okay? Okay? Jafari has a question. Hey, it's your neighbor. Not Jafari. Komba, you're welcome for the question. Eh? You have a question? You are welcome.
According to my understanding,
So I will be leaving this part. You will draw the waveform from the duplexer. What will be the waveform from the duplexer? That's what I will be leaving for you to draw. I won't draw. To test whether you are active or you are not active. Pardon?
Does it mean the duplexer works like an XOR gate?
XOR gate. What do you mean when you say that is XOR gate? There we have just the two states. XOR gate. Yes, that's the principle which will be used. So when the transmitter has information, that one will be switched. It depends how you define the states. When the one transmitting, you can define as high, and the ones at which is off, you can define as low. Did you understand? Okay, Komba was asking a question. Does the duplexer uses the principle of XOR gate? Look your neighbor. What's he doing? Look your neighbor. When Komba was asking a question, your neighbor was busy with some other issues. For instance, there, backbenchers are talking. They are sending signals. So I don't know, maybe by using duplexer or what. Okay. Komba asked me a question. And here it's a question. Does duplexer uses the principle of XOR gate to switch antenna to both transmitter and receiver? So answer that question. Hello? Why are you not writing? May I chase you out to go and buy exercise book and then come and write? Yeah. Who can try? Well, the response for that question is simple. Suppose that this is the transmitting antenna. Suppose that this is the receiving antenna. And suppose that this is just we say that transmitted the signal and the echo, or the output from the duplexer. We can call just the output from what? The duplexer. And then this is the truth table. So if this is the truth table, the transmitter and receiver will have what? This is just a question. Komba was trying to understand the principle of operations of duplexer by using the logic gates, and especially exclusive logic gates. So, if the transmitter and receiver does not have pass, and this one there's no echo, we say 0, 0. And then for that case, duplexer has nothing to switch, because the transmitter does not have information, and there's no any echo from the target. Right? Then another state, we say that when the transmitter has information, the receiver has to be switched off. By that time, the duplexer will allow the high power transmitted signal towards the antenna. Then, if the transmitter has already transmitted the information, the target reflected the radio wave or the radio frequency, and then we say that by that time, the transmitter will be switched off by duplexer, while the receiver will be switched on by the duplexer. Then for this state, for XOR, or the duplexer will allow the information in reverse from antenna towards the receiver. Then another state, if the transmitter wants to propagate information and receiver want to receive information simultaneously, it won't be possible. The duplexer by that time will tell them, hello, you cannot transmit and receive simultaneously. Electronics engineering is beautiful. Telecommunication engineering is beautiful as long as you learn with clear understanding and connect different concepts to build up the whole process. Are we together? Yes. Okay. So it's not a part. It's just a question from one of your classmates. This is question number 5. The truth table of 40 of duplexer. Remember that duplexer, it's not the multiplexer. It's not equal with the multiplexer. The duplexer, it's duplexer. The multiplexer, it's the multiplexer. However, that you may define, depends on the roots. If these are the two different sources, you may define just like a duplexer, that these are the two inputs, this is the single output. You may define it. But remember that in case of duplexer, it combines two different inputs to give one output. That's why I say they are not similar. Are we together? Keep this mobile phone for me. When you will give it to Matthew. Antenna so number 60. We have the next block we call it antenna. You have a question? Backbench? Huh? Antenna. Say antenna. Or radar antenna. I think that let us just have radar antenna. So what is the antenna? What is antenna? What the means of antenna? You don't know anything about antenna? You know nothing. Ask your neighbor, what is antenna? What do you understand about antenna? Ask your neighbor, what do you understand about antenna? Antenna is not a new vocabulary. You heard it, you read it, possibly even you use the concept. What is antenna? And listen the response of your neighbor. Don't ignore it. Where is your neighbor? This is your neighbor and that one. What is the antenna? Antenna is the antenna. What is the antenna? Antenna is your electronic circuit. Antenna is your communication circuit. Antenna is Sunday school. So you can define the word antenna by using different ways. But let me just give you one of the simplest definition that you'll never forget. Antenna is a transducer. Antenna is a transducer that conveys the electrical signal into electromagnetic waves during transmission. And it conveys electromagnetic waves into the electric signal during reception. This is one of the simplest definition that myself I learned it for more than 9 years ago, and I have never forgotten it. So firstly, what you have to bear in your mind, it's this. Antenna is a transducer. Say it's a transducer. Say it's a transducer. So simply you can say that it's the communication transducer. Can add up this one. It's a communication what? Transducer. Say transducer. Transducer, this might be electrical device or stop writing. A transducer might be either electrical device or electronic device or a communication device that is actually uses the principle of energy conservation. You remember in physics we taught you, especially Newton's laws of motion, that energy can neither created nor destroyed, but can be transformed from one form to another form. So whenever you discuss about transducer, actually this is the device which is converting one form of energy into another form of energy. A transducer does not create energy, and a transducer cannot destroy energy, but it just transforms from one form to another form. For instance, an antenna as a transducer, it will be transfusing or converting the electric signal or the electric energy into light energy. And also for the reception antenna, it will be converting the light energy, which we call the electromagnetic waves, into electric energy. These are the two different forms of energy. Remember that antenna does not create energy. Antenna receives energy and then transduce it into another form of what? Energy. Are we together? Are we together? So when the antenna transduces electrical energy into light energy during the transmission, when the antenna transducing what? Electromagnetic waves into electric signal during reception. Are we together? Whether it is transmitting antenna, its definition is there. Whether it is actual that is receiving antenna, its definition there. Whether you want just to discuss about transceiver, this is common definition. Are we together? Are we together? Okay. So he said that for this case, the same antenna the pulse radar, remember that, uses transceiver antenna. Transceiver antenna. So we want to have a transmitting antenna and receiving antenna. We'll have a single antenna. That means of transceiver antenna. Say transceiver antenna. So you say the antenna. Say antenna. Can you call your neighbor antenna? The nickname of antenna? Can you? The antenna transmit. The antenna transmit the amplified the amplified pass RF modulated signal towards. I'm about to end this class because I have another class, and yes, I think the material which I gave you are enough for today. So you say that the RF are the amplified pass RF modulated signal towards a distant target when the duplexer connects the antenna to the transmitter unit. So remember, during this moment, the receiver is disconnected from the antenna. So the duplexer is actually connecting the antenna to the transmitter while it disconnected the antenna from receiver. And then during reception, the antenna receive what? The antenna is being connected to what? Or duplexer connect the antenna to what? Receiver unit, while it disconnected the antenna from the transmitter unit. That's what I've taught you. So I'm just writing what I've explained to you. Okay, then we say that similarly, during reception of what? Of the echo during reception of the echo from reflected of the echo from the target, the duplexer disconnecting the antenna. Disconnected the antenna. So we say that from the target, the duplexer disconnect the antenna. Disconnect the antenna, the echo from the target, the duplexer disconnect the antenna from the transmitter, and they connect the antenna to the receiver unit of pass primary radar. So this is the second function of duplexer. Separating. Say during reception. Say during reception. During reception of the echo from the target, the duplexer disconnects the antenna from what? The transmitter. And connects what? And connects what? The antenna to the what? Receiver unit of what? Pass what? Radar, or pass primary what? Radar. That is for the purpose of what? Reception or receiving the echo. Okay? Yes. Then let us end with the waveform of received waveform of received receive the echo. So the waveform, remember that the transmitter transmits a very high power radio or pulse radio frequency or pulse the radio modulated pulse the RF modulated signal. And then do you know what happens to the receiver? The receiver receives very weak or low power echo signal from the distant target. Why? Because the signal, when the signal is transmitted to the long distance, actually it will be interrupted with noise, and in most cases, its energy will be attenuated. That's why we have, in electronics, we have amplification, and also we have attenuation. Say amplification. Say amplification. Say attenuation. Are you sure? So this is a received pulse. This is received pulse RF modulated signal. Engineering is all about what? Engineering is all about what? Ask your neighbor, how many graphs did you draw in this week? How many telecommunication graphs did you draw in this week? So this is the waveform of receive the echo. And this is figure what? Figure 6. The waveform of receive the echo. Homework. This will be homework 6. Explain the principle of operation of pass, primary or pass, radar, receiver, unit. So from the beginning, from the first block to the sixth block, we have been discussing about transmission. Just in the 60 block, we discussed both. Transmitted the signal and received the OT echo. So the other remaining blocks are actual blocks for the receiver unit. So the next lecture, which will be lecture 7, we'll discuss about principle of operation of OT, pass, radar, receiver, unit. So I would like to ask you to be ahead of what we are going to discuss. So go through it, learn about it, and then try to read and understand the function of each block. That's the homework 6. Is it clear? Yes. Is it clear? Yes. Yeah. So all of these descriptions of lecture 60, we cover the radar transmitter unit or the pass radar transmitter unit and the antenna. So in the next lecture, lecture 7, we'll discuss the OT, the principle of operations of OT, pass, primary, radar, receiver, unit. And if you have analyzed it, you have noticed that a receiver unit has a lot of blocks rather than transmitter unit. Why? Because in receiver units, in the radar receiver units, there's a lot of functionality that have to be performed until you extract the information about the target. Okay? Okay? Yeah. So, if that's the case, this is the end of lecture 6. If this is the end of lecture 6, let me know about physical and online students. Did you understand what we've been covering? Yes. Eh? Yes. Did you understand? Yes. Did you enjoy lecture 60? Yes. Sure? Can we congratulate you? Yes. Yeah, so let us congratulate you. Let us congratulate Jafari, who is chatting. 1, 2, 3. Hongera. Imara. Wow. So this is the end of lecture 60. Thank you very much. Welcome in lecture 7. If you want to be a serious student in our online diploma polytechnics of Tanzania, we ask you just to do one thing. Register yourself by just clicking the buttons of subscribe, and then you receive notification whenever we publish a new video. We have a plan, and actually it's a very serious plan. We always publish at least one video in a week about telecommunication engineering, about mechatronics engineering, about computer engineering, about electronics engineering, about biomedical engineering, and even about mechanical. But also we have some videos about basic engineering and scientific mathematics. So be a serious student, and let us meet in the next lecture. Thank you very much. May God bless you. Bye-bye. Mungu ibariki Tanzania, dumisha